Welcome to day 2 of our professional development, or Tuesday. Today we're going to cover some of the sticking points in units 3 and 4 of the APCSA content, which covers Boolean expressions and if statements, as well as iterations of for loops, while loops, those things. We're then going to look at misconceptions, common student misconceptions around Booleans and content flow. And finally, some evidence-based pedagogy, specifically the use of code visualizers and peer instruction, and talk a little bit about how you can implement those in your classroom. So first, let's dive into what are kind of the sticky topics in units 3 and 4. So in topic 3.4, so about halfway down after they've been introduced to if statements and else statements, we start to combine them. So it is a little bit different in the control flow if you have a series of if statements versus a series of if else nested statements. And so one of the nice ways you can visualize this in Codio is actually popping open our code visualizer. This is powered in the background by Python Tutor. We'll talk a little bit more about this in the pedagogy section. But what you're going to notice is with those else's there, you're going to check the first condition. See, it is not true. Grade is 89. It's going to go to the second condition. Is grade greater than or equal to 80? Yes. So it's going to print that out to our terminal up here. And it jumps all the way down. It does not check all of those. And that's not true. If you try this top program, you'll see quite a bit of stuff printing out because you don't see it jump the same way. So if I try this, make it look pretty, you're going to see I'm not seeing the same output. And so this is a really important point for students to really understand and be able to trace how Java is executing that code. Similarly, in Unit 4, there's definitely some struggle with following loops, but it gets taken up a notch when you get into nested iterations. So loops inside of loops, it starts to get really messy in that topic 4.4. And so, for example, we have them making this kind of square of octothorpes, hashtags, pound symbols, depends on how old you are, what you want to call it. And if you look at the code visualization on it, it just gets really hard to track what is the value of row and what is the value of column. And it's even extra messy when they use really simple letters like I and J, which the AP likes to do. And so I can track row is 0, column 0, and I can see that I'm going to increment column. And it does a pretty good job in the naming because I can see that my column count is doing my column. I'm going to scrub this a little. So now I'm, 1, 2, 3. I'm on my 4th row, which in computer science is a 3 because we go 0, 1, 2, 3. And I'm 1, 2, 3, 4, about 5 in to my columns. So this is well named. It's making a pretty predictable shape. And then it slowly gets more complicated if you want to do something unique on each row. And if you want to even change up the number of columns you have. So a couple of places where the control flow gets really interesting, those else ifs really trip students up, and the nested loops. Something to encourage them to do specifically when they have nested loops is actually make a table where in this case you'd have one column of your table be row, the next be that column variable, and the final one be output. The code visualizer will give you a snapshot in time, but to have the entire log of the program's behavior, really having that loop iteration table is super helpful. So those are some common sticking points in units 3 and 4 in APCSA. Now we're going to talk about misconceptions associated with control flow and Boolean expressions. So first, students get this impression that Booleans, and specifically Boolean expressions, are only used inside if statements and while loops. And if you use them outside of those two contexts in Java, it gets really upset. And so in this case, I'm using a not be in my return statement. That's not inside an if statement. That's not inside a while loop. And so students will think this is an error, that this is not acceptable. And so just making sure they get practice with Boolean expressions outside of the context of its if statements and while loops, just as plain Boolean expressions in code, can be really helpful. Similarly, students at this point, they've never seen code that really jumps around so much. It's been a really linear process for them, kind of like you read a book, start to finish. At this point, they really need to start understanding like code jumps around. It's kind of like those choose your own adventure books. You're not going to read every single page of that book. You're not going to go in exactly the same order. And so even though I have this function up here, I'm never calling it. So it actually doesn't execute this at all. And I'm only going to print goodbye. And even if I put the function call afterwards, like here, it would say goodbye, hello, even though my print statement that says hello is before my print statement that says goodbye. So once again, code tracing, when you have complex program or order of execution, is a really important skill. Great for bell ringers. What happens at this point in the program instead of just what is the output. Both conditional branches will be executed. So oftentimes students see that if else, and they think both is going to run, very similar to this other misconception of code is executed in the order it's written. They think it's really just going to read top to bottom. That's no longer the case. You're at a fork in the road. You go one or the other. You do not do both. And so in this case, they would think that both of these strings are printed because that's the order that you print less or equal to 5 and then greater than 5. You wouldn't just print, in this case, what, I have a 7. This is actually backwards. Look at this, debugging code live. Yeah, number is less than, yeah. In this case, it would now print greater than 5. So if statements constantly check the conditional, again, really lots of practice program tracing. They think the computer is magical, that it knows. It knows when you're doing something. It understands, and that's just not the case. It's really linear. It goes in order. It's a very traceable, followable step-by-step process. So num equals 0. If num is greater than 10, then I'm going to print bigger than 10. Okay, well, now num is 12. So the computer, knowing, hey, I care when num gets above 10, is going to magically print bigger than 10, even though that happens after my conditional. Not true, because again, we're going in a very specific order. Code tracing, this is very predictable. But if the students think that the computer is going to do anything logical or understand their meaning, this is going to get really confusing for them. So really practicing step-by-step, working through that flow of execution. While loops, same thing, constantly check for an exit condition. This is even more confusing because you're inside the loop. The while loop should know. It's a little bit different here. I've left my conditional, so okay, fine. But the same kids that understand that is incorrect might get tripped up when you get to loops. I'm inside the loop. This is always checking, right? Wrong. It only checks when it gets there in the process. Num is less than 5. Or sorry, num is 0. Num is less than 5. I'm going to do plus equals 1. So it's going to print 1. Then it's going to check. And then it's going to become 2. Print 2. Then it's going to check. 2 is less than 5. Print 3. Or become 3, print 3, come up here, check 3 is less than 5, 4, print 4, up here, 4 is less than 5, 5, print 5. Wait a second, why didn't I get kicked out of the loop when num equals 5? Because it goes in a very specific order. It's checking the condition, executing the entire loop body before it checks that condition again. And the same thing is true of for loops. It goes in a very particular order. So those are some student misconceptions that happen a lot around these topics of Boolean, some basic control flow with loops and conditionals, branching, selection statements, if else structures have a number of names. So let's go into a couple of pedagogical tools that are evidence-based and really work well in these topics. So the first is Code Visualizer, which I showed you a little bit already. Behind it is really just Python Tutor. So here's that same nested loop. And you can see the line that just executed and the next line to execute. So you can kind of see, well, I'm not actually going out to that external loop. I'm still in this column loop, and I can watch my variables change up here and my output change here. And this is all built into Codio. So if we go back to that page here, I can actually click Code Visualizer and it's going to pipe it right into that Python Tutor tool inside Codio. And I can have the exact same experience here. See if he wants to work right now. He's having a moment. Oh, there we go. And so I can have that exact same experience. You can scrub, especially like this is 354 steps. That's a lot of steps. So you can kind of get into the meat of this, resize, make sure you can see everything. Everything in Codio is resizable. And so I can really start to step through when it matters. There are some limitations that are documented, but again, really great to show the code execution, practice tracing it, all that stuff. The last piece of pedagogy we're going to talk about today is peer instruction. So the key tenets is assess, discuss, assess. It's a 3-step process. We actually have a webinar that Dr. Kristen Steven Martinez at Duke University did for us a while back on this topic specifically. And it's amazing, starts around 8.5 minutes in. And you can actually see her do an example live and talk about one of my favorite things from that webinar is her discussing how to write good, incorrect answer choices, like good distractors, if you will, for multiple choice, because typically peer instruction questions are multiple choice. So what you're going to do is have 2 identical Google forms. They can be as vanilla as, you know, question A, B, C, D, and you can just use that template over and over again and have the question on your board somehow displayed, whiteboard, projected on a slide, whatever. You could have the actual question inside the Google form, so it's a little bit clearer to you which question they're answering. You're going to have a couple of formative assessment questions. Usually you give 1 at a time. And so you would give a question like, what is the output of this little snippet of code? They're going to practice tracing it, etc. And they're going to enter into the Google form what they think the answer is. Then you're going to look and see, okay, we're branching. If more than about 75% of them get it correct, they understand it. You're going to move on. You're just going to explain it for the kiddos who didn't quite get it. Move on with your lesson. If only some got it, but it's about half, so between about 35 and 75%, you're going to have them discuss in small groups. And the goal of that is for students to convince their group mates to change their mind. Your group should agree on an answer by the end. And if you agree at the start, you need to explain why the wrong answers are wrong. So give them some discussion prompts there. And you're going to assess again individually. So they're going to agree as a group, at least theoretically, but they're going to enter into the Google form individually again. And so then hopefully most of them have been convinced to move to the right answer, and you would describe it, explain it, and move on. The last group or the last kind of scenario is they just completely bomb your question. They have no idea what's going on, less than 35%. So we're talking less than a third of the class understands. So at this point, you're going to need to give them some kind of hint before they go into the discussion and assess again, and then you would go into the explanation. And when you're going into the explanation, they've just had discussions about this. You don't need to be the only one explaining. It's a great moment to have people say why they think their answer is right, why they think this other answer is wrong, and allow students to have a lot of voice. And the nice thing is in these two bottom scenarios, they've already practiced putting together their thoughts in their groups. And so some of your students who are a little slower to speak have already taken the time to assemble their words and their argument. And so you'll get a slightly different set of people who are willing to participate often in these peer instruction exercises because they've had time to kind of test the waters in those little groups. And so they're more confident in sharing with a bigger class. If for some reason the discussion doesn't work out, if the second round of results, that second Google form is still really not great, we need to stop. And before moving on to the other content, we have evidence that they don't understand this. You need to really dive back in, maybe go back in your explanation, pull in another example. Do not move on if they do not understand, obviously. And again, peer instruction can be used multiple times during a lecture. The first couple of times you do this, it's gonna, like every classroom routine you ever teach your students, it's gonna take way longer than it should. The first time you run this, it could take 10, 15 minutes. So you're gonna open this Google form. This is how I distribute the Google form. This should be a really quick click. You're gonna have a discussion. This discussion's only 2 minutes. No, it's really 2 minutes. Stop talking. Okay, we're going to come back together. You're going to open this Google form. And it's a lot of changing and transition for them. And so once they have gone through it a few times, you can really get it down to a much tighter, like 5 to 7 minutes per question. But the first few times it definitely can balloon out to 10 to 15 minutes. But again, it's really helpful to draw the students in and get them discussing, thinking about their answer, talking to their peers, and hopefully getting students who don't necessarily share to the whole class possibly more comfortable to do that. So you can actually combine these two different tools together. So you can ask your question, have them answer, discuss, answer, and then use the visualizer as a tool to explain what is happening under the hood of the code. And students should be able to kind of dissect the visuals happening on the visualizer. They should understand these are variables. This is the output. This is the line being executed, and even use it as an explanation tool themselves if you're letting the students explain after that second round of Google form response collection. So really great active learning tool, keeps your students engaged. And again, another way to target those misconceptions, particularly for program flow. If you do it as an exit ticket and they don't do very well, it's a little more helpful to have this in the middle of the lecture and you can kind of address it right then if it feels like it's going to be a real sticking point. So that's the end of our day 2 topics. Tomorrow we're going to cover units 5 and 6, writing classes and arrays. If you want to go ahead and start working on that, you can, or you can do it after the synchronous session tomorrow.